Hey everyone, this is Nick Diobertis teaching you financial modeling. Today we're going to be talking about programming skills that are useful for more advanced financial models. This is part of our lecture series that introduces the new course on advanced financial modeling with Python and also closes out the first course on financial modeling with Python and Excel. So in the first course, we certainly cover, basic Python programming. Everyone completing that course should feel comfortable that they have kind of a handle on basic Python. Um, but we um, still are only getting really kind of a quick brush of everything. There's still a number of different um, areas of Python that we haven't explored, which would be used fairly commonly in more general programming settings. Um, and some of these are going to be useful as you go to expand to building additional models and data pipelines for those models and everything like that. Um, Thankfully, Python is one of those programming languages where you don't need to be an expert to get things done. Uh, as long as you have a handle on basic Python, you can manage to work your way through most tasks, and you don't have to, understand really advanced code structures, which are good for scalability and maintenance. It's good to learn those over time, but you can just get started, just kind of throwing some code in there, and it'll work. Um, but if you do go and learn better structure for your code and better and more advanced programming techniques, then all of a sudden new things become possible and things which were difficult before become easy. So there's a lot more to learn beyond what we've already looked at in the first course. And beyond just thinking about Python programming, there are also general software engineering practices that we can look at and learn from in order to become better financial modelers as well. So, looking at some of those general programming things we can learn from. Um, so, these are the kinds of things that um, software engineers that build software all day are doing on a day-to-day basis, and that you don't see as often in the finance industry. But um, it's good to learn from these things to become better programmers and build better financial models because of that. So, um, if you're going to take one thing away from this lecture, it should be that you should use a version control. Version control is a way of tracking the code over time in a project. You track not only the code over time, but all the changes that are being made to the code. And it also allows multiple people to work on the code a lot easier. Um, Without going into a lot of detail here, you basically can create separate branches of the code, which means that um, people can start from the same code and go in different directions with it, and then you can merge those branches back together later. So both people can be working on the code at the same time, changing different things about the code, and then you ultimately bring it together without having to go through a big manual process to do that. Most of this is going to be automated um, through the version control software. Um, and because you have this full history, um, you can do things like, well, I'm going to just try something really experimental. I'm going to tear apart the code, totally change it. And then if it doesn't work out, well, I'll just go back to where I was before. You have basically the entire history of the project, every change that's been made throughout. Um, so this is a really, really useful skill to learn for programming. Um, Highly, highly recommend that you learn this. Um, especially if you're going to start working in teams for your models. Then it becomes even more necessary. But even as an individual working on a project, it's still very useful because you can always revert changes if they don't work out, and you can go and try things. And maybe you're trying something and it's not working out, but you want to come back to it later. Well, you just leave it in this branch over here. You go back onto the main code. You can keep doing whatever changes, and then when you have some free time, come back to this branch and try to get it to work out. And you can even bring over the changes that you've made in the meantime from the main branch. So becomes way more flexible to work with the code, and you don't worry about losing anything. So I use this for every single programming project that I do, no matter how big or small. So I highly recommend that you do this. And Git is the gold standard here. There used to be other options which people used fairly commonly, like Mercurial and Subversion, but Git is nowadays what everyone is using. So it's really not even a decision anymore. Just use Git for your version control. And then Git itself will work just locally on your machine, not being hooked up to anything. But you can kind of supercharge Git by sharing that repository, that Git repository, uh, into some kind of platform. GitHub is by far the most common place, and if you look up basically any open source project, it's on GitHub. The Git repository is shared through GitHub. And what this allows is it makes your code public, or you can have private repositories as well. But allows much easier sharing of the code with others. So then once you have the code on GitHub, someone else can come and pull that code down and make some changes, and make a request to merge their changes back into the main code. And so it enables a lot easier collaboration in a very organized way. Automated testing is another general area of a general pattern that we can use, that we can draw from the software engineers. And automated testing is a little bit meta. It's writing code which checks that your code is working properly. So you might think with your model, you go and you run it and you check and you look at the results and make sure the results are sensible, right? And that's your testing. But you could also say, I know if I put in this input into the model, I know I'm supposed to get this output. Now you just write some code that says, hey, run the model, get the output from the model, compare that output to my expected output. If those things don't match up, then throw an error. The test fails. If they match up, then do nothing. The test passes fine. So then you just run this code which tests your code anytime you make changes, and then you can ensure that you haven't broken the functionality. So this is basically essential for building large applications, and so software engineers do this all the time. But we can bring that over to our financial models as well, especially in larger, more complex financial models that have a lot of different parts. You can kind of test each part individually to ensure that nothing is breaking as you go and add additional changes. Input validation is basically checking that the inputs are in the way that you expect to get them. So are they the correct data types? Are they in the type of range that you would expect? If it's a retirement model and you're putting starting salary, if it's a negative number, then you throw an error saying, oh, starting salary can't be negative. Or if it's, they try to put ABC, the string for the starting salary, then you're going to also throw an error. Starting salary should be a number, not a string. So it's not, necessary to do this for your model, but it's nice for when other people, if you have other people just using your model directly, because they may not totally understand what the all the inputs are supposed to be, and so they make mistakes in setting up the inputs. And what this validation does is it will just immediately tell them exactly what that mistake is. You know, you gave a string when it should have been a number for the starting salary, versus if you just let it fail in your model. Well, it's like now you're trying to like add a string and a number, and it's like, oh, can't add type str to type float, and then you just see this long stack trace, and that's what the user of your model sees is this weird error, and they think that your model is broken. They don't think that they used it incorrectly. They just think it's broken because they see this weird error they don't understand coming out of it. So if you have that input validation, then the error is going to say exactly what they did wrong. And so they'll be able to fix that rather than coming to you and saying, hey, this thing broke. Can you help me because it broke? And then you go and you say, oh, well, you used it incorrectly. Here's how you use it. Just, saves you that whole issue. Um, and then if you're starting to go to this, in the financial modeling with Python and Excel course, we generally cover just having everything in one Jupyter notebook. And so Jupyter is serving as your IDE. But if you start to go to the structure where you're going to offload code into separate Python files and have a really more mature project structure, then I would recommend going to using an integrated development environment, IDE, in order to help you write that and maintain that code. So PyCharm and VS Code are the two that I would recommend. They are by far the most popular in the Python space. And generally, I would say if you're really focused on writing Python code, go with PyCharm. It's really built for Python. If you know you're going to be writing Python code, but you're also going to be writing in other languages as well, then VS Code can be a better choice because it's more natively multi-language support. And also, if you have very limited system resources on your machine, then probably go for VS Code because it's a more lightweight editor. But PyCharm definitely does do a better job specifically with Python, so that's why I recommend it if that's primarily what you're doing. And then we have this whole concept of continuous integration, continuous deployment, or CI/CD for short. And that's basically thinking about all the things that you might have to do in your project. Like, for your financial model, it might be running the data pipeline to get the data, and then running the model, and then generating the report from the model, and then, maybe emailing that report to somebody. You can automate all these steps, and that's referred to as a CI/CD pipeline. So you can do all those things I mentioned for a financial model, or if you're building a Python package, you can also, deploy that Python package, or if it's a web app, you can deploy the web app. You can have it automatically format your code so it looks nicer. You can have it run all the tests, the automated tests that you've written, make sure that nothing breaks. So this is just all about automating as much as possible in the process. So that's the general programming topics, and then we have some additional Python topics as well. So one thing that we didn't really cover is working with files on the file system. We covered working with Excel files, loading them in through pandas and Excel wings. But you can just work with more generally any kind of file using the built-in Python modules OS, pathlib, and shutil. So check those out. One basic data type we didn't cover in Python are sets. So sets have unique items, and they're not ordered. So it's just, you have a bunch of different things. It takes the unique ones of those. But you can also do intersections between sets. You can do unions. Intersection being what are the overlapping things between these two sets, union being take all the things from both sets and put them into a new set, etc. So it definitely have certain applications. And then there's we covered a little bit working with classes, but we didn't cover at all how to customize the built-in behavior of Python objects using dunder methods or double underscore methods. So that's um, like how we use the fin statement library in the class, and when you look at a financial statements object from that library, it prints out the whole income statement and the balance sheet, right? So how me as the creator of the library, how did I get it to do that? When you just look at the financial statements in a Jupyter cell, it was setting one of these dunder methods. Particularly there, it's underscore underscore repr repr is able to set that. And for Jupyter, you have repr underscore HTML, which is going to be the HTML representation of your object. But this is just an example. You can override basically any behavior of a Python object. So you want to add two things together and want to make it display an animation? Sure, you can do that. You override the underscore underscore add method, and that's going to make it run whatever logic you define there when you add two of these objects together. So actually in the fin statement library, you can take two financial statements and add them together, and it will go and add all the different financial statement items together. So I have that logic implemented on the financial statements class in the dunder add method. There it has the logic to go through each of the statement items and add them together, and then create a new financial statements object and return that. So you can basically totally change the way that you work with Python by creating really interesting packages by overriding these dunder methods. We only looked at one decorator in the course. That was the data class decorator, which converts a regular class into a data class. But decorators allow you to modify a class or a function. So you just place it above the definition and it will modify it. So that's definitely a more advanced pattern, but it can be useful in certain cases. Like maybe, you have a bunch of functions in your model, and normally they don't really print anything out. You just ultimately get the output at the end. But you're debugging the model, and so you want to see, what's getting spit out for each step of the model. Maybe you have a decorator which you put on the top of every function, and depending on the value of some variable, it either prints the output or doesn't print the output. And then you just change this one variable, and then that will make it all of a sudden that every function is printing its output. You switch it back, and now none of them are printing the output. So lots of different applications. There's just an example. Then we have this concept of pickling. So pickling is a way to take a Python object and put it into a file, such that you can later in a new Python session load that file and get your Python object back. So if you have some kind of custom classes in your model that you need to store, this can be a good way to do it. And then type annotations are a way of adding a little bit to your Python code to say what type everything is. Is it a string? Is it a float? Is it a list? Is it a list of floats? Is it a list of strings, etc.? And this will make it easier to read your code because it's clear what type of data is flowing through. And when you use an IDE, it's going to really kind of uh, make it a lot better experience, because you'll see in your IDE, well, if you say, this thing is a string, and then you put a dot on the end of it, well, it will suggest all the string methods for you right there. Or if you then try and add that to something which you've set as a number, it'll highlight that immediately. You haven't even run the code, but it highlights it immediately and says, oh, you can't add a string to a number. Because it understands that one is a string and the other is a number, it's going to know that that will raise an error once you do ultimately run it, and it's going to highlight it before you ever even get there. So you can catch your mistakes a lot sooner with the combination of an IDE and type annotations. So definitely recommend going in that direction. And then, again, in the first course, we discussed, just having everything in one Jupyter notebook. That's not really a good long-term structure. You want to split out your code into modules and packages. So modules are just text files that end in .py that have Python code in them, and packages are just folders which have a certain Python module called init.py, and then it has modules inside of it as well. So nothing too complicated there, but it helps you keep things really well separated and reuse code between different models and projects. And then virtual environments are a way of basically isolating everything for one project, all the packages that you're using in that project, keeping them separate from another project. So it may not be clear why you would want to do this as someone who's just getting into Python. But any experienced Python programmer is going to be using these things religiously, because they have run into issues when they haven't used them. That's kind of the natural progression. You just have all these projects going everywhere. You're not really thinking about the environment, and then something breaks in one project and it affects other projects, and all of a sudden all your things are broken and you're just like, what is going on? Nothing works anymore. Everything is broken on all my projects. Like, this is a nightmare. And that's why virtual environments are really necessary here. If you're only ever going to have one Python project on your computer, you don't need a virtual environment. But as soon as you think about having multiple projects, you should definitely consider using virtual environments, because it totally isolates one project from another project. And then looking at the resources, so I'm providing a lot of links on all these things so you can go out and learn them on your own. I do want to post videos on some of these topics, but in the meantime, you'll have these resources. So here's one to get started with Git and GitHub. And then there are apps out there that make working with Git and GitHub easier. GitHub Desktop is one of those. An introduction to automated testing and input validation. The two different IDEs that I mentioned, PyCharm and VS Code. An introduction to CI/CD, and then looking at actually doing CI/CD using GitHub and GitHub's built-in CI/CD system, GitHub Actions. Working with files in Python, both an intro and going to more advanced usage. Then looking at how to use sets, how to work with these dunder methods to customize object behavior. Some more resources on data class, additional things we can do with data classes. How I can basically achieve, the financial statement display in the fin statement package in Jupyter. How you can specifically add that or whatever you want to display for your particular classes. How you can get started working with the decorators to modify existing classes and functions. How you can pickle these Python objects to store them for later with pickle and dill. a introduction to type annotations in Python, how to better structure your Python projects with packages and modules, an introduction to virtual environments and why you might want to use them, what they are, as well as a package called pipenv that makes working with virtual environments easier. So that's an overview on additional programming topics that are useful as you start to get more advanced with financial modeling in Python. So thanks for listening and see you next time.